Hello everyone, my name is Nehit Kumar and I am the Chief Manager Sustainability at Arvind Limited. Today I am delighted to share that we have been selected as part of the Apparel Impact Institute's Climate Solution Portfolio Program, a recognition of our efforts to accelerate decarbonization within the textile industry. The project which has been selected is biomass torrefaction using cotton stock. The grant amount is $400,000, which will be used over a period of 2 years. Before moving on to the project, I'll briefly take you through what we do as Arvind. So, Arvind Limited is a textile to retail conglomerate which was founded in 1931. And over the decade, we have grown into one of India's leading integrated player across textile, garment, advanced material, and environmental solutions. We straddle the entire value chain of textile and apparel, starting from partnering with farmers for sustainable agriculture, spanning to cotton spinning, fabric weaving, dyeing, finishing, garment manufacturing, and lastly to retail. Denim has been our heritage, but our operations now span woven and knit fabrics and also garment and retail. Fundamentally right has been our sustainability philosophy, and sustainability has been a cornerstone of our strategy. This project represents a bold step in tackling one of the hardest to abate challenges in our industry, which is coal dependency in thermal processes, specifically the use of steam for dyeing and finishing. Sectoral challenge. So right now in countries like India, where natural gas is not that easily accessible, coal dependency is highest, specifically for tier 2, which uses coal for their dyeing, finishing and other processes. The existing decarbonization options that a tier 2 faces are either too expensive or technically unsuitable. First one is renewable electricity. It is not practical for large scale steam generation due to the high cost, high space use, and also the conversion inefficiencies. The second one is replacing the boilers with an agro or a biomass or an electric boiler, which demands high capital expenditure, especially when many existing boilers still have useful operations left. The third one is biomass co-firing, which only partially substitutes coals, limited to about 20-30%. If we go beyond this, there are operational inefficiencies in boiler, and it does not eliminate the dependency on coal altogether. This reliance on coal is a major roadblock for decarbonization in textiles. And without scalable solution, it becomes difficult for the industry to align with global climate commitments. So this particular solution of torrefaction is applicable to facilities in tier 2 and where the coal usage is above 5 tons per hour and the cost of renewable electricity is high. Also, where there are limitations in terms of the total renewable electricity capacity that you can have as an organization. Solution. So at Arvind, we are piloting a 100 tons per day torrefaction plant, which is the first of its kind in India using cotton stock, which is being supported under the CSP program. So no previous torrefaction plants have been done at this scale, specifically using cotton stock. So thus the design, control, process stability all needs to be proven. The second point is the input of this torrefaction plant is cotton stock, which in itself is variable because cotton as a commodity is as an agricultural commodity. So the moisture, the composition in terms of the cellulose content, the hemicellulose content or the lignin content varies across cotton stock. So how this um, raw material can be used to create uniform torrefied fuel output and performance needs to be figured out. The third one is fine tuning of torrefaction parameters because right now torrefaction is a thermochemical process which uses the agricultural residue or any input material is heated in an oxygen deficit environment at 200 to 300 degrees Celsius to reduce its moisture and volatile contents and convert it into energy dense biomass. So for this conversion process, the torrefaction parameters need to be fine tuned. When we say torrefaction parameter, these are temperature, the residence time, how much cooling time is needed, so that the material that we get as output can be used in the existing conventional boilers. And the last barrier that CSP is helping us scale or resolve is, right now industries are very unfamiliar with the torrefied biomass properties. What will be its calorific value, what will be its density, what will be its price, how will it perform. So these are some barriers which the industry are not able to solve. So thus CSP will help us to de-risk and support us in commissioning first of its kind 100 ton per day plant. Second, it will help us undertake controlled pilot trials which are needed to optimize the process flow and to ensure stable operations. Thirdly, it will also help us experiment on what are the process parameters which will be needed to really get the torrefied output that we need for running in a conventional boiler. And lastly, AII will help us create and disseminate technical case studies so that the wider industry can adopt it. So talking in more details about our solution. So as I previously mentioned, torrefaction is a thermochemical process that decreases the moisture and volatile contents in it. This is done by heating biomass, specifically cotton stalk in our case, in an inert or an oxygen deficit environment at 200 to 300 degrees Celsius. This will convert the cotton stalk into an energy dense biomass as similar to coal in appearance and properties, thus eliminating the need to replace boilers. The different activities that we aim to undertake under this project is to finalize contract with technology partners and undertake site selection, securing permits for it, completing the energy design, so that we have detailed schematics which are needed to convert cotton stalk feedstock into a torrefied biomass output. The second activity that we'll undertake is to fabricate and procure the torrefaction unit and its other components that are needed to establish this torrefaction plant, conduct pilot trials to refine the process parameters, validate the fuel properties, and ensure that these fuel properties of the torrefied output is compatible with the conventional coal-fired boilers, and then finally ramp up the production of our torrefaction plant to full capacity of 100 tons per day. The last activity that we'll do under this program is to develop case study which will focus on the technical and economic performance, and these case study will be distributed to the wider industry via Apparel Impact Institute and other industry platforms. And lastly, we'll also obtain sustainability certifications like sustainable biomass in order to make sure that the biomass that we are using in our boiler is sustainable and traceable. Moving on to the goals. The goals under this project is to understand both the technical and environmental side of it. So when we say technical validation, we want to understand, can cotton stock be torrefied at scale? How do we maintain consistent fuel quality despite variation in feedstock? Can torrefied biomass meet the performance standards of industrial boilers as well as industrial buyers in terms of price point? So the learnings that we'll get out of this project is, can torrefaction be done at scale? What will be the operational challenges like handling its variable feedstock, maintaining throughput, and confirming the financial model's robustness? If this project is successful, thus a single 100 ton per day torrefaction plant will be able to reduce approximately 55,000 tons of GHG emissions annually. So over a period of 5 years, this will be able to save 275,000 tons of CO2 emissions. And lastly, the final impact of this project will be to validate phase out of coal without needing of a high capex boiler replacement. So once the project stabilizes, we intend to scale these solutions. When we say scale this solution, we ourselves want to scale it from a single 100 ton per day plant to 200 300 ton per day plant, so that we have our reliable biomass supply for internal decarbonization and meeting our science-based targets. The second is this particular program will help us create a replicable model of 100 to 200 ton per day modular unit, which can be deployed across other agri residue regions where there's abundant cotton stock and similar feedstock. The third one is knowledge sharing. Out of this project, we will disseminate learnings through industry case studies, site visits, webinars, and use opportunity provided by knowledge sharing platforms like Apparel Impact Institute and Cascade. So our vision is to create a blueprint for coal elimination in thermal process across the textile industry. And this we are not doing just for urban. It's a solution that can be replicated across the textile industry. So our solution is going to contribute to the 2030 goals by decarbonizing tier 2 operations, which is hard to abate, and providing a commercially viable drop in fuel for existing boilers. At the end, I just want to emphasize that this project is about proving what's possible. It is about taking a hard to abate sector, finding a scalable, replicable solution, and sharing it with the world. On behalf of Arvind, I want to thank Apparel Impact Institute and the Climate Solution Portfolio Program for their trust and support. Together, we can accelerate the transition towards a low carbon future for textile and beyond. Thank you.